Let's uh, let's take another problem from the chapter of friction. The problem says that the frictional coefficient between a road and the tire is 4 by 3. Find the maximum incline of the road may have so that once hard brake is applied and the wheel starts skidding, the vehicle going down at a speed of 36 kilometers per hour is stopped within 5 meters. So, if we have understand the problem first, then let's try to draw the diagram. It says that it indicates that there is an inclined road. So let us draw an inclined road. You do not know this angle theta because this theta they want us to find the maximum incline. And this is a car. Let's say this is one wheel of the car, right? And what it says that after hard brakes are applied, try to understand the problem clearly. It says once hard brakes are applied, that means both the handbrake and foot brakes are applied, that the engine is stopped. Then what happens? The wheels will not move any further. The car will only slide down. That means the car will be like a block of a wood or iron. That's all. Car will slide down, and it says the car was coming with a speed of 36 kilometers per hour. That means the car had an initial velocity. Initial velocity is 36 kilometers per hour, which is equal to 36,000 meters, and 1 hour is 36,000 seconds. That is equal to, so it is clear the speed was 10 meters per second. We have to bring everything into the MKS unit. Now what happens? Once again, the car has a downward force mg, and it has a force g cos theta, mg theta normal to the plane, and same is the reaction force R, which is also equal to mg cos theta. The car is, there will be a inclined component of this mg. This mg is from mg sine theta, and as the car will start sliding down, the frictional force F small f will act upward along the inclined path, And of course, the car will have an acceleration, downward acceleration. Say this acceleration is A. Once we have understood this problem this way, then the remaining solution becomes easy. But it says the vehicle is stopped within 5 meters and it was coming with a speed of 10 meters per second. So we can always find out the acceleration using the formula v square is equal to u square. Now it will be minus because there is a retardation, 2as. From here, we find v is 0 is equal to u square is 10 square minus 2a we do not know, s is 5 meter. From here, we find acceleration A is equal to 5 meter per second square. This will be an important value that we shall need to solve this equation. Next, let us find what is this frictional force. If we find out the frictional force, we first find out the value of R. R is equal to, frictional force is mu R. F is equal to mu R, where mu is given as 4 by 3 is equal to 4 by 3, and R is mg cos theta. That means m into g tan cos theta is not known to us. So, sorry, not theta, mg cos theta. So it is 4n cos theta. So this is equal to 2 by 3, 4 by 3 n. Then you write the force equation along the incline. We can, for your remembering, I write force equation slope. You write force equations along the slope. Then the car is coming downward. So what is the downward force? So, and the frictional force is upward. So downward force is mg sine theta. Now here, in fact, we should remember once again, should put it clearly. Let's not write A here. Because the car is coming down with a retardation. Car is coming down with a retardation. It is gradually stopping. So, vectorially speaking, the acceleration A is upward. Acceleration A is upward. Though car is moving down, you can say velocity of the car is down. Now, if you try to draw the force equation, then what we normally do, we first write the forces towards the acceleration. The forces towards the acceleration is F, which is equal to 40 by 3m. And what is the force in the direction opposite to acceleration is mg sine theta, is m theta. This is equal plus m into acceleration A. A is known. I repeat once again here. When you write the force equation, you first write the force towards the acceleration. Then only your equation of P is equal to F equal to ma will apply properly. The force towards the acceleration minus the force in the opposite direction is equal to ma. That is how to write it. Now, let us come from here to here. This is 40 by 3. And in this equation, m, n, m all gets cancelled. So 40 by 3 cos theta by 3 cos theta minus g is 10. So 10 sine theta is equal to A, equal to A. A value of A has been found. So here there was a mistake. I am sorry. The value of A was not 5, since I didn't show the complete calculation. Value of A is 10 meter per second square, right? A is 10. From here, we get A is equal to 10. From here, we get 4 theta, 4 cos theta minus 3 sin theta is equal to multiply by 3 and divide by 10. Cos theta, we have to find out the value of theta. So in place of cos theta, we write whole under root 1 minus sine square theta minus 3 sine theta is equal to, or we can write 4 under 1 minus sine square theta is equal to 3 plus 3 sine theta plus 3 sine theta. Now, if you square both sides, you will find it is 16 into 1 minus sine square theta. This is 16 is equal to, here we have 9 multiplied by 1 plus square theta plus 2. If you simplify this equation, simplify this expression, we'll find that 25 sine square theta plus 25 sine theta minus jump one step. So you'll find 25 sine square theta plus 18 sine theta minus 7 equal to 0. If you factorize this, you will find it is sine theta plus 1 multiplied by 25 sine theta minus 7 is equal. From here we get sine theta is equal to minus 1 or sine theta is equal to 7 by. Now, what is sine theta is equal to minus 1? What is sine theta equal to minus 1? Sine theta equal to minus sine inverse minus 1 is equal to minus 90 degrees. That means it indicates that the slope is like this, vertically downward, which is absurd. Ignore. Absurd. So we find sine theta equal to 7 upon 25. And from here, if you calculate, you will find theta is equal to 16.26 degree. So answer to this question is 16.26 degree is the maximum incline. The maximum incline possible is 16.26 degree. Take another similar problem where a car is going at a speed of 21.6 kilometers per hour. It encounters a 12.8 meter long slope. That means this slope is 12.8 meter. With that angle, 30 degree. This angle is 30 degree. The friction coefficient is 1 upon 2 root 3. Once again, when the car comes here, the mu is 1 upon 2 root 3. So that no matter how hard the driver applies the brake, the car will reach the bottom with a speed greater than this. Anyway, the point is the driver has applied a hard brakes. If the driver has applied a hard brake, then what happens? Then the car only keeps on slipping down, or which in the driver's language it's called skidding down. It skids down. So let us try to solve this equation. Here, what are the things which are given? The points given is mu is 1 by 2 3. G is equal to 10. It's not mentioned in the sum, but you have to consider it. And it also says final velocity is 36 kilometers per hour. It's 36 kilometers. He is equal to 36 kilometers per hour. Right? And the car was final. That means that when the car comes here at the bottom, it is V, 36 kilometers per hour. But when the car hits the slope, here U is given 21.6 kilometers per hour. Now, let us do these things. So try to solve this one by one. First, we have to find out what is U. We find out U in terms of meter per second. It is 21.6 multiplied by 1000 divided by 606 meter per second. This is equal to 6 meter per second. And the V is also given 36 kilometer. Is 6 into 1000 divided by 10 meter per second. So we have both the velocity in terms of the entry system. Initial velocity U is 6 meter per second. Final velocity V is 10 meter per second. Here also, the car is simply skidding down. If the car is simply skidding down, then maybe we write the formula. We draw a picture like this for clear understanding. A picture like this for clear understanding. Say this is the car wheel, which is skidding down. The wheel is not rolling because hard brake has been pressed. Once again, this is the downward force, vertically downward force mg. This is the force mg cos theta perpendicular to the plane. This is the force m sin theta parallel to the plane. And this is the reaction force R, which is nothing but mg, which is nothing but mg cos theta. And now let's try to solve the problem. R is mg cos theta. The reaction for R is mg cos theta. N is G is 10, so it is 10 N, and the angle theta is 30 degree. 10 N cos 30 is root 3 by 2. Root 3 by 2 is equal to root 3 N. So R is 5 root 3 N. If R is 5 root 3n, then the frictional force which is trying to stop the car, F, is equal to mu R. Or mu is given 1 upon 2 root 3, 1 upon 2 root 3. R is 5 root 3. So this is equal to F equal to 5 by 2. F is equal to 5 by 2. So we have found F. Now we equate the forces along the motion of the car. And say car comes down with an acceleration of A. Let's say. So as we said earlier, you first write the force which is towards the acceleration. This is mg sine theta minus what is the force opposite to the acceleration is F. This has to be equal to mass into acceleration. From here we get g is equal to 10 n sine theta is half sine 30 minus f is given 5 by 2 m. F is mu r, sorry, r had a component of m here, so it will be 5 by 2 m. R is 5 by 2 m is equal to, all the m's gets cancelled. So from here we get 5 minus 5 by 2 is equal to A. Therefore, acceleration A is equal to 5 by 2 meter per second square. But they have not asked us to find the acceleration. They asked to find out the final velocity. The final velocity, you can use the formula v square equal to u square plus 2as, where s is given 12.8 meter. S is the length of the road, 12.8 meter total displacement. And we have already found out u is 6. Therefore, final velocity v is equal to 6 square, that is 36, plus 2. Acceleration A is 5 by 2, multiplied by S is 12.8. Here you will find V is equal to 10 meter per second. V is equal to 10 meter per second. That means if V is equal to 10 meter per second, which is equivalent to, we have already calculated, it is 36 kilometer an hour. That means if the car applies the hard brake, then also it will come down with a total acceleration of 36, total velocity, final velocity of 36 kilometer an hour. So we complete it here. Next day, we shall see more examples.